Well, we have another question here, question 2.2. The question says, given the arithmetic sequence 35, 28, 21, and calculate which term of the sequence will have a value of negative 140. Well, I'm gonna write the question here, question 2.2. So when the question says which term of the sequence, so it refers to n, okay? So the unknown here is n. We're looking for n. So we're looking for n if Tn equal to negative 140. Now let me write the sequence here. Okay, first of all, when they said arithmetic sequence, we understand that we're talking about the constant difference, which is given by d. So let me write the sequences. I say they're like 35, 28, 21, and the case 3. Now let's find the constant difference. The difference between the terms. I'm gonna do 28 minus 35. This is equal to negative 7, and then 21 minus 28 is negative 7. So the constant difference is negative 7. Therefore, I can write Tn like this. Tn will be equal to negative 7n. And I said to myself, if I have negative 7, how much must I add to negative 7 in order to get 35? So it's like negative 7 plus what? Let me write it over here in different color. So it's like negative 7 plus what equal to 35. So x must be equal to 42. Okay, so I'm gonna write negative 7n plus 42. That's Tn. Otherwise, we can just use the formula. Okay, saying like Tn equal to I'm gonna write the formula here. Tn equal to a plus n minus 1 times d. Okay, so if you're unsure to do as I did, you can use the formula, that formula in red, and then over here I can just write Tn will be equal to a, the first term, which is 35, plus n minus 1 times negative 7. So we can just times negative 7 by n, and then negative 7 by negative 1, and this will be Tn equal to 35 minus 7n plus 7, and this will be Tn equal to negative 7 plus 42. So the same values. Now that the question says which term will have a value of negative 140, we can just write negative 7n plus 42 equal to negative 140. Now I will move 42 over. Okay, so this will become negative 7n equal to negative 140 plus 42, and that makes negative 7n equal to negative 182. Actually, I meant minus 42. Yeah, so that makes negative 182. Now, if we divide both sides by 7 or by negative 7, I'm gonna do it over here. So I have like negative 7n equal to negative 182. So if I divide by negative 7 here and negative 7 there, so we have n equal to, I can see this is equal to 26. If I'm sure, you can use a calculator, do negative 182 over negative 7. So this is equal to 26. So meaning negative 140 is the 26th term. So n equal to 26. Now the following question. The following question is question 2.3. The question says that for which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? Now, I will prefer to move my board over here. I'm gonna say here 2.3. So basically, they said for which term of n, so meaning we're looking for n, okay? for which term of n, let me read the question again. I'll move it over here. I prefer to read it over. It says, for which value of n will the sum of the first n terms of the arithmetic sequence in 2.2? So in 2.2, the arithmetic sequence is the sum, okay. In 2.2, we know, let's see, 2.2, we did work it out here. We found Tn was equal to -7n minus 42, that's Tn. We can see that over here, Tn equal to, as I said, Tn is equal to -7n minus 42. And then because we don't know the last term, I'm going to write this formula for the sum of n value. The sum of n term, I mean, Sn will be given by n over 2, open square brackets, 2a plus n minus 1 times d. Okay, this is Sn. And then previously, in the previous video, we did also we found Tn of in Tn for the quadratic sequence over here. We did find that Tn was equal to 3n squared. That was equal to 3n squared minus 8n minus okay. Plus 7. In the previous video, we did this, plus 7. Now, we're going to basically to find the value of n for which Sn and Tn here, Tn equal to 3n squared minus 8n plus 7 are equal. Now, okay, Sn, let's work out Sn. Sn will be equal to n over 2, 2a, okay, plus n minus 1 times d. So I'm going to sub in the values. A, the first term is 35, and then d is -7. And now this will be n over 2, open square bracket, 70, plus actually -7n plus 7. Okay, and then this will be equal to n over 2, open square bracket, 7 plus 7 makes 77, and then minus 7n. And now this will be -7 over 2n squared plus 77 over 2n. So this is Sn in question 2.2. Now in question 2.1, let me write here. In question in 2.2. Now in 2.1, as we said, Tn was equal to 3n squared minus 8n plus 7. Now we are going to, what can we do then? Set them equal. Okay, we're gonna make 2.2 equal to 2.1. Okay, let's say here 2.2 equal 2.1. Now this will be -7 n squared, -7 over 2n squared plus 77 over 2n equal to 3n squared minus 8n plus 7. Now, I think one of the easier way is to get rid of the fraction. So we're going to times the whole equation by 2, and then this will become, let's do this way, our times here by 2, our times there also by 2. Okay, times here by 2 also. And then this will become 7n squared plus 77n equal to 6n squared minus 16n plus 14. Okay, so then I will prefer to move, okay, those elements. What are, okay, I'll move whatever on the right hand side to the left hand side. Okay, and then this will become 7n squared minus 6n squared plus 77n plus 16n, and then minus 14 equal to 0. So now 7n squared minus 6n squared makes n squared, and then 77n plus 16n, this is equal to that makes 87. 87 plus 6 will be 94. Okay, so actually 93. So I picked plus 93 n minus 14 equal to 0. Then oh, I think I made the logical mistake. I mean, a mistake here. There was a -7 there, so that makes this is -7, yes, plus 77. All right, so now it's -7 over here, and then -7 minus 16 makes -13. So that makes -13n squared plus 93n minus 14. So over here, I can times by negative sign. This will become 13n squared minus 93n plus 14, yeah, equal to 0. Now we can solve this by factorization, or we can use the quadratic formula. I think the numbers are quite larger. In this situation, I prefer to use the quadratic formula. Okay, so I will move my board this way, or I can just use it up here. The quadratic formula is given by x equal to minus b plus minus square root of b squared minus 4ac all over 2a. Okay, this is because the quadratic equation is ax squared plus bx plus c equal to 0. Now we have a quadratic equation here, so that's the formula we're going to use. This is the formula we're going to use. Now I will, in this case, our x, the unknown is n, so we can just write n there, minus b, okay, plus minus square root of b squared minus 4a, and then times c all over 2a. So I can sub in the values, okay, minus b is -93, so -93 here, plus minus square root of -93 to the power of 2, minus 4a, a is 13, and then c is positive 14 over 2a, 13. Now let's just use a calculator, and now okay, over here it's -93, it's not that clear. -93. Okay, now let's use a calculator, and I use there on the right here, negative open bracket -93 close bracket, and then plus. I cannot use plus minus here, so I can use them separate. Let's first work out the plus. Open bracket -93 to the power of 2. Nope. To the power of 2 minus 4, open bracket, a is 13, close bracket, and then c is 14, close bracket. Close bracket. Okay, now over 2a, 2 open bracket, 13, close bracket. Now when we hit equal, we have like n equal to 7, one of the values 7, so n equal to 7, or we can also work out also the other with the negative, so this will be I'm gonna change the plus here by minus there, equal n equal to 2 over 13. Now you know that n must be a positive integer, so n equal to 2 over 13 is not applicable, so the solution is just n equal to 7. It's only one n equal to 7. Okay, the 7th term will make the sum of quotient 2.2 equal to the quadratic equation. Thank you.